Hello everyone, welcome to the next lecture on the Laplace transformation. Today I will explain you how you can find the Laplace transformation when integration appears in the problem. I will explain you this lecture with the help of the 30 examples so that you can learn it very simple manner. You can simply follow my YouTube channel where there is a playlist of the mathematics 2 and you can see the various lecture on the Laplace transformation. And you can see the last lecture was on the Laplace transformations from 0 to infinity. That lecture I have explained you in my this one solved example of the Laplace transformation. But right now instead of the 0 to infinity, today's lecture is from 0 to t. How you can solve, you can see that each problem is from 0 to t. Either it has a single integration or it may have the more than one integration. So the rule is very simple. Whenever you want to evaluate from 0 to t, that is this quantity, fine. So you can replace the single integration to be 1 by s and then find the Laplace transformation of this number. That is the rule of this Laplace transformation, fine. If it is a double integration from 0 to t, then you have to divide it by 1 by s square. If it is a triple integration from 0 to 2, then it's a s cube and so on. Now the proof is very simple. You can get the proof in a single one line answer. So firstly you can see I need to target this one. So I can simply take phi of t is this number, 0 to t f of t of dt. So therefore can you find the derivative of this? What is the phi dash of t? Derivative and integration will be cancelled out. It is f of t. And what is the phi of 0? So what is the phi of 0? You can see phi of 0 means 0 to 0. Integration of 0 to 0 is my 0. Fine. Now what is given to you? The Laplace of f of t is my fs. This is given to you. Now substitute the value of the ft. Ft is my Laplace of phi dash of t. Fine. Now I can apply the definition of the derivative. What is the derivative rule? S Laplace of phi t minus phi of 0. Fine. Now you can substitute that. What is the phi of 0? Is a 0. Can you find the value of the Laplace of phi t from here? It is 1 over s f of s. So what is the f phi of t? Phi of t is my integration. That means your target is to achieve that. So that's the answer of this question. And you can see I can summarize them in a simple manner. You can substitute what is the phi of t. Phi of t is my here and you will get the required answer. Now let's see how you can solve them. Your target is to find the Laplace of this number. So again a very simple, since it is a single integration from 1 over s. Make sure student always remember the integration should be from 0 to t. If it is from 0.0001 to t, then it is not equal to 1 over s. It must be from the 0 to the finite number. Fine. Now, so again your target is to find here. So it will be 1 over s Laplace of the remaining quantity. Now how you can find the Laplace of this? So that's a very simple, because the exponential term present, I can apply the shifting first theorem. So what is the Laplace of the cos? Is s over s square plus 1. So therefore by shifting first theorem, Laplace of e raised to power minus t cos of t, it will be replace s to be s plus 1. So that is the here. So I can substitute this value here, 1 over s plus 1 over s plus 1 square plus 1 is the right answer of this problem. Look at this second one. Your target is to find the Laplace of this. Now you can see it's a 0 to t. It's a 1 over s Laplace of e raised to power minus of t sine hyperbolic 2t. So I can start with the Laplace of sine hyperbolic 2t. It will be a over s square minus a square. So therefore by you have to return this proper manner by the shifting first theorem, we get Laplace of e raised to power minus t sine hyperbolic 2t. It will be replace s to be the s plus 1. So 2 over s plus 1 square minus 4. So the right answer is 1 over s twice s plus 1 whole square minus 4 is the right answer of this problem. Look at this another one. So your target is to find the Laplace of this number. So what is the rule of this polynomial? It is minus 1 raised to power 1 first times derivative of this remaining quantity, 0 to t e raised to power minus of t sine t over t. Fine. So I can firstly find the Laplace of this quantity. So what is the Laplace of this quantity from 0 to t e raised to power minus of t sine t over t? Fine. So or I can do in a very simple manner. I can start from the easiest one. What is the Laplace of the sine t? It is 1 over s square plus 1. Then what is the Laplace of sine t divided by t? Now it is a divide sign, so it is from s to infinity Laplace of sine t. So what is the integration of this? It's a tan inverse s from s to infinity. So that will be pi by 2 minus tan inverse s, that is cot inverse s. Then you have to multiply by e raised to power minus of t. How you can do that? By using the shifting first theorem. I have to replace s to be s plus 1. Fine. Then your target is to find the Laplace of this integration. What is the rule of the integration? It's a 0 to t. So you have to divide by s. So 1 over s cot inverse s plus 1. So I can got this number. It's a minus d by ds of cot inverse s plus 1 over s. Now you can take the first time derivative. What is the derivative of this quantity? S square s. What is the derivative of the cot inverse? 1 over s plus 1 square plus 1 into 1 minus, I can put cot inverse s plus 1 here, derivative of the denominator quantity. So that is the right answer of this problem. Or you can little bit simplify it. What is the simplified form of this? It will be, I can adjust the minus minus plus s over s plus 1 whole square plus 1 minus minus plus cot inverse s plus 1 divided by s square. So I can written 1 over s square is the right answer of the problem. Now your target is to find the Laplace of this quantity. Now since it's a triple integration, so it's a s cube Laplace of t sine of t. So how you can find the Laplace of t sine t? That means it's a polynomial of degree 1 minus 1 raised to power 1 first derivative of sine t, Laplace of the sine t. So what is that? It's a minus d by ds of 1 over s square plus 1. So what is the derivative of this? Minus 2s over s square plus 1 whole square. So that is 2s over s square plus 1 square. I can substitute here 1 over s cube into 2s over s square plus 1 square. Fine. So 1s will be cancelled out. So 2 over s square plus 1 whole square is my right answer of the problem. Again, your target is to find the Laplace of this. So clearly say this exponential quantity pair. That means we have to use the shifting first theorem. So firstly I can find the Laplace of this quantity. So again I can start from the Laplace of this. It is my 1 over s square plus 1. Then I can apply the rule of sine of t divided by t. That come to be integration from s to infinity s square plus 1 of ds. So that is tan inverse s from s to infinity. So pi over 2 minus tan inverse s, that is cot inverse s. So now I can use the Laplace of 0 to t sine of t by t. So what is that? What is the rule of this integration from 0 to t is 1 over s cot inverse of s. So now what is the Laplace of this? I got the Laplace of this as here. Now by using the shifting first theorem, you get the answer as replace s to be s plus 1. So that is the right answer of this problem. Always go with this step by step. Firstly find the Laplace of this, then divide, then integration, and then exponential. Again here, again you have to go with the step by step. Firstly find the Laplace of cos of t. So Laplace of the cos t is my s over s square plus 1. Then I can multiply by t. So that means that is a minus 1 raised to power 1 first derivative of this. So can you find the first derivative of this? Minus the denominator will be s square plus 1 whole square. It is s square plus 1 into 1 s of 2s. Now you can see it's a negative 1 minus s square over s square plus 1 whole square, or I can adjust the negative sign. So s square minus 1 s square plus 1 whole square. Then you can integrate them. So therefore what is the integration Laplace of 0 to t cos of t? So that will be 1 over s of this answer, s square plus 1 whole square. Fine. Now exponential term present. So by using the shifting first theorem, I have to replace s to be the s plus 1. So it is s plus 1 whole square minus 1 divided by s plus 1, and this number will be s plus 1 whole square plus 1 of square is the right answer of this problem. Now Laplace of this value. So it is a 1 over s Laplace of cos of at. What is the Laplace of the cos at? S over s square plus a square. So s will be cancelled out. 1 over s square plus a square is the right answer. Or you can also do the same question by here. You can firstly integrate them. What is the integration of the cos? That's a sine of at from 0 to t. So that will be Laplace of sine at minus sine 0 will be 0. So what is the answer of this? This a over, sorry, if you integrate them, it is over a also. So this is a s square plus a square. So that will be cancelled out. 1 over s square plus a square. Fine. So both the way you can solve them. But if somebody will return that using the Laplace property, evaluate the Laplace, then you have to solve by this manner. You can't solve by this way. Now how you can do that? Again, you can the first way is you can integrate by parts, but that is not possible. So that means you have to apply the properties. How you can solve them? I have to multiply by 2 divided by 2. Fine. So it is a 1 over 2. Integration means 1 over s, or before that I will tell you easiest way. This one, integration rule is 1 over s Laplace of sine 3t cos 2t. Fine. How you can solve them? I can multiply by 2 divided by 2. Then what is the formula for the 2 sine a cos b? It is sine a plus b Yes, student. Plus sine a minus b. Yes, you are correct. This one. So it will be 1 over 2s Laplace of sine a plus b 5t sine a minus b sine of this. Now can you find the Laplace of this value? It is a over s square plus 25 plus 1 over s square plus 1 is the right answer of this problem. Now this is there. Again you have to find the Laplace of this. It is my 1 over s Laplace of e raised to power t sine cube of t. How you can find that? Again this exponential appears means shifting first theorem. So firstly I can find the Laplace of the sine cube. So sine of cube will be appear from the sine of 3a. So what is the formula for the sine 3t? It will be 3 sine t minus 4 sine cube t. I can find the value of the sine cube t. So that will be 3 sine t minus sine 3t divided by 4. So I can find the Laplace of this. What is the Laplace of the sine cube t? 1 over 4 will be outside. What is the Laplace of this? 3 over s square plus 1. It will be 3 over s square plus 9. Fine. So now I can take the LCM, or that's on your choice. So 3 over 4 is outside. I can take the LCM as s square plus 1 and s square plus 9. So it will be cancel out. It is 9 minus 1, 8. So this will be cancel out. 2. So it is a 6 over s square plus 1 into s square plus 9. So that's the Laplace of this. So how you can solve this? By using the shifting first theorem. So I have to use shifting first theorem. I have to replace s. Remember, you have to replace s to be the s minus 1 only of this term, not outside this Laplace quantity. So this is s minus 1 square plus 1 and s minus 1 square plus 9 is the right answer of this problem. Again your target is to find the Laplace of this. So it will be 1 over s Laplace of t e raised to power minus of t sine of t. So let's start with this one. So I can start with the Laplace of the sine t. It is 1 over s square plus 1. This is the shifting first theorem. You can apply the shifting first theorem firstly, but I will start with the sine of t. So that is the first derivative with the negative sign of this number. Fine. What is the answer of this? What is the first derivative of this? Minus 2s over s square plus 1 whole square. Fine. It will be 2s over s square plus 1 square. Now I can use the shifting first theorem. What is the shifting first theorem? S to be the s plus 1. So this is s plus 1 divided by s plus 1 square plus 1 of whole square. So that is the right answer of this problem. Fine. Otherwise you can find the after this one you can apply the shifting first theorem firstly. That is e raised to power minus of t sine of t. It will be 1 over s plus 1 whole square plus 1, and then you can apply the derivative rule. That will again give you the same answer of this. So what is the first derivative of this? Minus 2 times s plus 1 over s plus 1 square plus 1 of square. Now you can see minus minus plus, and you can see the same answer as here. Now your targets again apply the Laplace of this value. Fine. This will give you the shifting first theorem. Fine. So I can start with the Laplace of sine square. How you can find the Laplace of the sine square? It is 1 minus cos 2t divided by 2. So that comes to be half is outside. Laplace of 1 is 1 over s. Laplace of the cos is s over s square plus 4. Then I have to take the derivative also. So I can take Laplace of t sine square t. So that comes to be, now you have to take the derivative. What is the derivative of 1 over s? It's a minus 1 over s square. What is the derivative of this? I can take s square plus 4 whole square. It is s square plus 4. S will be 1 minus s into 2s. Fine. Now I can open this bracket because it's the first derivative is with the negative sign. So minus first derivative. So it's a minus 1 over s square. It is 4 minus s square over s square plus 4 into square. Fine, this is my square. So that is the derivative. Now what is the integration rule? So therefore Laplace of 0 to t sine square of t, it will be 1 over s. It will be 1 over s into this part. Fine. Now by using the shifting first theorem, you have to replace s to be s plus 3. So whatever the answer you have written here, you can replace s to be s plus 3. So that into this minus 1 over s plus 3 whole square minus 4 minus s plus 3 whole square divided by s plus 3 whole square plus 4 of this number. Fine. Now if you want to take the LCM, then you may take, otherwise this is the right answer. Okay, look at this one. Again your target is to find the Laplace of this. So this again give you the shifting first theorem. So this value will give you the 1 over s of the Laplace of this. So firstly I need to find the Laplace of this value, sine 3t cos 2t divided by t. How you can find that? Because it's a division by t, so it's a s to infinity Laplace of sine 3t cos 2t, fine, into ds. How you can solve that? I can multiply by 2 divided by 2, so it will be s sine of a plus b and sine of a minus b of ds. So that will be half s to infinity. What is the Laplace of sine? 5 over s square plus 25, and it is 1 over s square plus 1. So can you find the integration of this? So 5 is outside. Integration of the 1 over x square plus, so 1 over a tan inverse s over 5 plus 1 over a tan inverse s from s to infinity. So that 5 will be cancelled out. So it's a half. Tan inverse infinity is a pi by 2. Tan inverse infinity is a pi by 2. Tan inverse s over 5. Tan inverse s. So pi by 2 plus pi by 2, that is my pi, minus tan inverse s over 5 minus tan inverse s. Fine. So that is the Laplace of this. So therefore what is the Laplace of this integration part? Therefore Laplace of this integration part, it will be 1 over s of this quantity, 1 over 2 pi minus tan inverse s over 5 tan inverse s. Now what is the remaining is exponential. So using shifting first theorem, what is the answer of this? Laplace of the required term is, I have to replace s to be s minus 4. So it is 1 over s minus 4. It is a pi minus tan inverse s minus 4 over 5 tan inverse s minus 4. This is the angle. So that is the right answer of this problem. Look at this another one. You have to find the Laplace of this value. Laplace of the integration is again 1 over s. Laplace of e raised to power here cos of bt. Also, if you want to integrate by parts, then you can do it. But if somebody will ask you using the Laplace properties, then you have to use these properties here. So what is that? It's a 1 over s. What is the answer of this? So I have to find because the exponential term present, the shifting first theorem must be applicable. So the cos is s square plus b square. So therefore, by using the shifting first theorem, exponential of a raised to power t of this, it is s minus a square plus b square. So I can substitute here s minus a square plus b square is my right answer of the problem. Again, you have to find the Laplace inverse of this. So it is 1 over s Laplace of e raised to power minus of 2t cos of 3t. So what is the answer of this? I have to find the Laplace of cos 3t. It is s over s square plus 9. So Laplace of e raised to power minus of 2t cos of 3t. By using the shifting first theorem, it is s plus 2 square plus 9. So I have to substitute here. It is s plus 2 square plus 9 is my right answer of this problem. Again, you can solve by parts also. Firstly, you can by parts and then integrate it. Otherwise, your target is to find here. Remember, the first method is you have to firstly solve by parts. There is a first function, integration of the second function, fine, and then after the calculation you get the Laplace. But that will take a very lengthy procedure, fine, unless you never know what is a Laplace. So easiest way is you can solve like here, fine. Now you can see what is the Laplace of the t. It is my 1 over s square. So therefore, using shifting first theorem, always remember, whenever the exponential term will present, always use the shifting first theorem. Always use the shifting first theorem. So what is the answer of this? T of e raised to power minus, it will be 1 over s plus 3 square. Now I can substitute here. It is 1 over s into s plus 3 square is the right answer. Also, you can solve by another way also. Firstly, you can find the Laplace of e raised to power minus 3t. It is 1 over s plus 3. Then you can apply the rule of this multiply by t. What is the rule of the multiply by t is, because the degree is 1, so the first derivative of this quantity. So what is the derivative of this quantity? It is minus 1 over s plus 3 whole square. And you can see it's a minus minus plus, again you will get the same answer as here. That's a very simple. The first method is you have to find the Laplace of this. So it will be 1 over s Laplace of this. So it will be 1 over s minus 2 is the right answer. Other way is, if you are not using the Laplace, firstly you can integrate them. What is the integration of this is? This is my integration from 0 to t. It will be e raised to power 2t divided by 2 minus 1 over 2. Fine. Now you can find the Laplace. it is 1 over s minus, and Laplace of the 1 over 2 is 1 over 2 of 1 over s. So half will be common. It is s minus 2, 1 over s. Now you can take the LCM. 1 over 2 s minus 2, s plus, now you can see s will be cancelled out, 2 will be also cancelled, so 1 over the same answer as here. And you can see in this case you need to do later build calculation, but here you can directly find them. Again you can see about here how you can find the Laplace of this. 1 over s, Laplace of sine 2t cos of 3t. So again multiply by 2, divided by 2. So again you can use the same rule, 2 sine a cos b, sine a plus b plus sine a minus b. So that comes to be 1 over 2s sine a plus b, so sine of 5t, sine a minus b, sine a minus b will be minus of t, so that will be sine of t. So what is the Laplace of this quantity? 1 over 2s, 5 over s squared plus 25, 1 over s squared plus 1 is the right answer of the problem. So these questions are exercise for you. You can solve it and let me know your answer in the comment box whether you get the same answer or not. These are the another 5 questions. You can see the 10 questions I have provided you. Check whether these you will get the same answer or not. Let me know your answers in the comment box. Thank you very much students. I hope you can share this video with your friends. Best of luck students. Happy luck.